In last class, we have discussed about mixed RC potential divider. Now we shall read about the mixed RC potential divider for 2 megavolt rating and above. Okay. Voltage dividers used for measuring more than 1 million volts. It will attenuate the criteria required to assess the dividers. The shape of the voltage in the test arrangement should be transferred without any distortion to the LV side. Okay, the shape of the voltage in the test arrangement should be transferred without any distortion to the LV winding side. The simple determination of transfer behavior should be ensured, and they should have suitable for multi-purpose use with AC power frequency voltages, switching impulse voltages, as well as lighting impulse voltages. This condition necessitates the deviders should have a broad bandwidth. The above requirements are generally met by optimally damped RC dividers and underdamped or low damped RC dividers. Okay, these above conditions can be met by optimal damped RC dividers or underdamped or low damped RC dividers. The high voltage arm of such dividers consists of series RC units, while the secondary arm is usually RC series or parallel circuit. Okay, the high voltage arm of such dividers will consist of a series RC units, while the secondary arm is usually RC maybe series or parallel circuit. In case of optimally damped dividers, R1 is equal to 4 square root of L1 divided by Cg, where L1 is the inductance of the high voltage lead and HV portion of the divider, and Cg is the equivalent capacitance to ground. Usually this resistance will be 400 to 1000 ohms. On the other hand, for low and underdamped, till now we have learnt about the optimally damped dividers. Now underdamped or low damped dividers. Okay, R1 will be equal to 0.25 to 1.5 times square root of L divided by C1, where L is the inductance for the complete measuring loop and C1 is the capacitance of the HV part of the divider. This is for underdamped dividers or low dividers. This is optimally damped waveform. Okay. Response time 50 nanoseconds, front time 50 nanoseconds, overshoot equals to 3%, parameters R1 is equal to 1000 ohm and C1 is equal to 360 picofarad, damping resistance 500 ohm, RD plus R1 close bracket C1 equals to R2 C2. Next, underdamped response time is 4 nanoseconds, front time is 110 nanoseconds, overshoot 30%, parameters R1 is equal to 256, C1 is equal to 400 picofarad, damping resistance that is R1, C1 is equal to R2, C2, zero resistance. Step response of a 4 megavolt RC divider. In the case of normal value of R1 lies between 50 to 300 ohms. The step response of the two type of dividers mentioned above shown in this figure 7.36. Okay. In actual practice, because of the large time constant, that is RD plus R1 plus RD plus R1 into C1, the optimal damped divider affects the voltage shape at the test object. Optimal damped divider will affect the voltage shape at the test object. Standard lightning impulse sometimes cannot be generated to the correct standard specification. The standard lightning impulses cannot be generated. It cannot generate the correct standard specifications. Mixed RC potential divider are not suitable for measurement with test objects of very low capacitance. You need to remember this. Mixed RC potential divider are not suitable for what? are not suitable for measurements with test objects of very low capacitance. The low or underdamped RC dividers acts as a load capacitance, and it is suitable for applications over a broad bandwidth. Low or underdamped RC divider, it will act as a load capacitance, and it is suitable for the applications like which applications which have the over bandwidth, okay, over a broad bandwidth, like switching impulses, lightning impulses, chopped waves, etc. Underdamped RC dividers are also suitable for measurement of steep fronted impulse waves. Okay, it is also suitable for steep fronted impulse waves. A typical record of lightning impulse wave, that is 1.2 1.2 divided by 50 microseconds wave, obtained using both the type of dividers. This you can observe record of the front portion of a lightning impulse wave with underdamped and optimally damped. Curve A is underdamped and curve B is optimally damped. Okay. In the case of underdamped dividers, again the step response is poor. In the case of underdamped dividers, they can be used to measure the standard impulse wave to better accuracy. Step response is poor in the underdamped waves or underdamped dividers. They can be used for standard impulse wave to better accuracy. Different connections employed with potential dividers. These are the different connections. Resistance potential divider with surge cable and CRO. Capacitance divider with surge cable and CRO. Next, split capacitor arrangement. Next, resistance potential divider with surge cable and CRO. Voltage ratio is V1 divided by V2 is equal to 1 plus R1 divided by R2 plus 1 divided again R1 divided by R2, where R2 is equal to Z0. A simple arrangement of resistance divider. This is what they have been. First one, the possible errors are R2 is not equal to Z0, that is surge impedance of the cable. Next, capacitance of the cable and CRO shunting R2 and hence introducing distortion. Okay, what are the errors? R2 is not equals to Z0 and capacitance of the cable and CRO shunting R2, and it will introduce a distortion and attenuation or voltage drop in the surge cable, that is Z0, and ground capacitance will affect. These errors are already discussed in last classes. Okay, in previous classes we have discussed about these errors. To avoid reflection at the junction of the cable, R2 is varied and adjusted to give the best possible step response. To avoid these type of errors or reflections, that is to avoid reflections at the junction of the cable, and R2 will be varied or adjusted to give the best possible step response. When a unit step voltage is applied, okay, for example, if we apply any unit step voltage for a circuit, then the effect of the cable is to take a fraction of the voltage, that is C1 divided by C1 plus C2 into it, okay, and it will cause a reflection at the input end. Whatever, if we apply any unit step voltage to the circuit, then the effect of the cable is to take a fraction of the voltage and it will cause a reflection at the input. In the beginning, the cable acts like a resistance. In the beginning, the cable will act as a act like a resistance, that is value is equal to Z naught, the surge impedance, but later it behaves like a capacitor of value equal to the total capacitance of the cable. Starting it will behave like a resistance and it will but later it will behave like a capacitor. Okay, the behavior introduced distortion and it is compensated by using a split capacitor connection. Okay, what distortion is introduced that can be compensated by split capacitor. Okay, that can be compensated by split capacitor, that is C1 plus C2 is equal to C3 plus Ck, that is Ck is the capacitance of the cable. On the other hand, Ck divided by C1 plus C2 plus Ck is equal to 0.1. The error will be less than 1.5%. This is the RC series divider, modified connection of RC divider. R1 C1 is equal to R2 C2, Z0 is equal to R3 plus R1 into R2 divided by R1 plus R2. Impedance matching with RC divider, mixed potential divider arrangements. The arrangements for mixed RC potential divider, the arrangement that is shown in the figure is modified and improved in the arrangement. R1 C1 is equal to C2 Z0 open bracket C3 plus C1 plus C2 plus Ck close bracket divided by C1 plus C2. Z0 is equal to R3 plus open bracket R1 R2 divided by R1 plus R2 close bracket and R1 C1 is equal to R2 C3. This is C3. Okay. The response is greatly improved and it will give a simple and it gives the desired impedance matching. Next topic is peak reading voltmeter circuit. Sometimes in this ENOF, if the peak reading voltmeter circuit of an impulse voltage wave is measured, its wave shape might already be known or fixed by the source itself. They are saying that peak reading voltmeter circuit of an impulse voltage wave is, it can be measured. Its wave shape might already be known. That means we may know that wave shape of that is known and it is fixed by the source itself. Okay, we can fix the source wave shape and we can fix the source. Okay, by source itself. Its wave shape might already be known or fixed by the source itself. This is highly useful in routine impulse testing work. The methods are similar to those employed for AC voltage crest value measurements. The instrument is normally connected to the low voltage arms of the potential dividers described in 7.27. Okay, in last classes we have discussed about this. The instrument is normally connected to the low voltage arms of the potential dividers described in this section. The basic circuit along with its equivalent circuit and the response characteristics is shown in the figure. The circuit consists of only rectifiers. Okay, basic circuit, equivalent circuit and waveform of input and meter voltages showing error delta. Diode reverse resistance is assumed to be infinite. A peak reading voltmeter and its equivalent circuit. Diode D conducts for positive voltages only. Diode D will conduct for positive output, positive voltage only, because starting positive and it is negative. Okay, when you apply positive cycle and the diode will be forward biased, so it will conduct. For negative pulses, the diode has to be connected in reverse. Okay, the diode will become reverse biased. When a voltage impulse V of t appears across the low voltage arm of the potential divider, the capacitor Cm is charged. They are saying that when a voltage impulse appears across the low voltage arm of the potential divider, the capacitor is charged to the peak value of the pulse. Okay, capacitor will charge to the peak value of the pulse. When the amplitude of the signal starts decreasing, when the amplitude of the signal will start decreasing, then what happens? The diode will becomes reverse biased. Okay, when the amplitude of the signal starts reducing or decreasing, the diode will become reverse biased and it will prevent the discharging of the capacitor. Okay, the voltage developed across Cm is measured by a high impedance voltmeter, that is electrostatic voltmeter or electrometer. Okay, you can observe here across Cm there is a EVM or electrometer. Okay, it is for measuring the voltage. Okay, the voltage developed across Cm is measured by a high impedance voltmeter. High impedance voltmeter and electrostatic voltmeter or electrometer. As the diode has finite forward resistance, it has a finite forward resistance. The voltage to which Cm is charged will be less than the actual peak of the signal, and it is modified by the RC network of the diode resistance and the measuring capacitance Cm. The error can be estimated if the waveform is known. This is the peak reading voltmeter for the either polarity with resistance divider and capacitance divider. Okay, this is the diagram of that A and B. Okay, here R1, R2, RR. Okay, here C1, C2, C capacitance connected, Cm. Till this one similar for even capacitance divider and resistance divider. What is this part? Only this part will change. Okay, the actual forward resistance of the diode is difficult to estimate, and hence the meter is calibrated using an oscilloscope. Peak voltmeters for either polarity employing resistance dividers and capacitance dividers. In this arrangement, the voltage of either polarity is transferred into a proportional positive measuring signal by a resistive or capacitive voltage divider and a diode circuit. Okay, peak voltmeters, the actual forward resistance of the diode is difficult to estimate, and hence the meter is calibrated using an oscilloscope. Okay, before we have used electrometer. Peak voltmeters for either polarity employing resistance dividers and capacitance dividers. Okay, we have seen here. In this arrangement, the voltage of either polarity is transferred into a proportional positive measuring signal by resistive or capacitive voltage divider and a diode circuit. Next, an active network with feedback circuit is employed in commercial instrument so that what happens, the fast rising pulses can also be measured. Instruments employing capacitors dividers require discharge resistance across the low voltage arm to prevent the building up of DC charge. Next topic is measurement of high direct current. High magnitude direct current are measured by using a resistive shunt of low ohmic value. It can be measured by using a resistive shunt of low ohmic value. The voltage drop across the resistance is measured with a millivoltmeter. The voltage drop across the resistance is measured with a millivoltmeter. The value of the resistance varies, usually 10 microohm and 10 milliohm. This will depend on the heat effect and the loading permitted in the circuits. Measurement of high direct current resistors are usually oil immersed and are made of 3 or 4 terminal resistance. The voltage drop across the shunt is limited for few millivolts, that is less than 1 volt in power circuits. Okay, the value of the resistance will depend on the heating effect and the load permitted in the circuit. And measurement of high direct current resistors are usually oil immersed and are made of 3 or 4 terminal resistance. The voltage drop across the shunt is limited to few millivolts. Next is Hall generators for DC measurements. This I will explain in the next class.